Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to our webcast, SpecSizer 201, Intermediate Tips and Tools, brought to you by Caterpillar. I'm Mary Windishart, today's moderator, and we have just a few quick items to go over before we begin. At the bottom of your console, you'll see a number of widgets that will allow you to have greater control over the way you view the webcast. To download today's slides, just click on the Resource widget, and you'll see the Download Slides link. At this time, we recommend that you disable your computer's pop-up blockers. This will allow the slides to advance automatically throughout today's event. At any time during the webcast, you can submit a question by simply typing it into the Q&A box and clicking Submit. We'll answer as many questions as we can, but if we aren't able to get to your question today, we'll respond to you directly after the event. If you experience any technical problems, please visit our webcast help guide by clicking on the help link below the video window. Our speaker today is Stephen Baker, Market Development Consultant, EPD Marketing. Stephen leads the development and training for Caterpillar's generator set sizing tool, SpecSizer. Stephen began his Caterpillar career with machinist and degree option apprentice programs and received his BS from Bradley University in Peoria in Engineering and MBA Foundation. He graduated to factory supervisor, later working as a manufacturing and systems engineer, and then as NPI program project manager in the SEP Small Engine Group. Steve joined Electric Power in 1999 as a retail assistant NPI program manager and led Six Sigma projects as an Electric Power Black Belt. He then transitioned into his current role, managing the sales tool development, support, and training for generator set sizing. Welcome to you, Stephen. Hello.
Hi, Mary. Thank you. Well, we've got about an hour to spend with you today. Back in September, we did a SpecSizer 101 training course, and a lot of things that we talked about back then had to do with accurate genset sizing. But today, we're going to talk about some tips and some tools that you can use with the SpecSizer application to size basically a smaller kW kVA genset. So let's go ahead and get started here. You know, the first thing that I want to talk about, I like to talk about, over the years I've worked thousands of customer and dealer inquiries with SpecSizer, and I like to talk about actual inquiries that I've seen where we were able to help a customer out. And so what you're looking at here is a real application. It was a power plant over in India. I got an email from a customer, and the following day, an email from the dealer, and they said, we've got this application. It's about 12 or 13 megawatt, and we'd like to send you the sizing file, and can you help us size a smaller genset, a better fit for this application? Well, I looked at the sizing file. It was 19 load steps. And basically what it had to do with, in conversation with the customer, it had to do with something called duty point percent or load factor. In conversation with the customer, I learned that the duty point or the load factor of all 19 loads was not 100%. It was just 75%. So we're going to talk about that application right now. We're going to get into that. First of all, I want to define duty point for your load factor. Really what we're talking about there is your average load divided by your peak load. A lot of people get confused about this. It's not really that difficult to understand. Just think about it again as your load factor, your average load divided by your maximum load in a given time period. And again, I've seen people get tripped up. They think that we're talking about the genset, which would be standby, prime, and continuous. That's a generator set duty. That's the average power output divided by the typical peak demand. But here in this case, we're talking about the load. We're not talking about the genset. We're talking about the load. And so, what we're going to be talking a lot about today is what can you, as the user with SpecSizer, to do to optimize your genset sizing. There are different sizing parameters that are associated with your loads, different calculated values. You can see here at the bottom of the slide, in your load analysis summary, you've got your inrush, which is your SKVA and your SKW, and you've got your running KVA and KW. Now I'll tell you, There are several things in a sizing tool in an application that you can do to reduce the inrush or the starting, but there's only one thing that you can do to reduce the running. And when I talk about running, I say that that's the sort of the price of admission. Your size genset has to at least meet or exceed the running kW and kVA of your loads, what your loads calculate. So here we're looking at duty point load factor. Again, we were looking at ways to optimize the application. When I first got this sizing file, the duty point was 100% for all 19 loads. We were able to reduce that to 75%. That's what the customer said it could be. Here you see the load dialog for a three-phase motor. You see duty point percent. You see where you can reduce that. What we were able to do is reduce the size gensets from 8 parallel 3100 kW gensets to 6 3100 kW gensets. So that's a substantial savings for the customer. These are big gensets. They're some of our biggest. Our largest diesel gensets that we offer today are 4,000 kW, 4,000 kVA. So if we can save you, the customer, that much value, basically reduce 2 generator sets, that's really a good benefit, a good value for you. Now, I'll also mention that there was a competitive sizing on this, and the competitor sized one more than 6 gensets. They actually sized 7 3,000 kVA gensets. So again, a good opportunity for the customer, but always remember with a sizing application, whether it's SpecSizer or another one, there's only one thing that you can do to reduce the running kVA and kW, and that's the duty point percent, okay?
You know, we have some questions for you. We're glad that our participants are sending them in. The first one is duty point the only thing you can do to downsize a generator set?
Yeah, that's a good question, Mary. You know, a minute ago I alluded to there were some other things that you can do to reduce the size of the genset. There are several things that you can do to work with the inrush. As I mentioned, we're going to talk about those more as we get into the presentation. One of the main things that you can do is something called reduced voltage starters. Another is low inertia motors, and again, as we get into the presentation here, I'm going to talk a bit more about those.
Before you go back, just want to remind everyone that we'll answer as many questions as we can. If we aren't able to get to your question today, we will respond to you directly after today's event.
Okay, so we're going to continue to talk about some other tips that you can use then to optimize your genset sizing. Okay, you know, I had already mentioned inrush running. There's another sizing parameter, I call it, that your loads will calculate. That is the harmonics, the distortion. All your loads create inrush running, harmonics, distortion, and your size genset then has to be large enough to meet that demand, that inrush running distortion demand. So what we look at here, I think what's important to understand is that when you look at these sizing values that you see in the load analysis summary, that load analysis summary is on your add loads page and your select genset page in SpecSizer. What's important to know, remember, understand is that any value that's kVA is related to your alternator, your genset alternator, and any value that's kW is related to your genset engine. So if you're trying to reduce the size of your genset, if you're trying to reduce the size of the engine, you're working with your kWs, your RKW, your SKW, your running and starting. If you're trying to reduce the size of your alternator, your kVA, your RKVA, and your SKVA. And then there's another value here that we can see. It's called TKVA. That's your total kVA. That's your alternator kVA plus that for the harmful effects of distortion, okay, and harmonics. So another value then that we work with and we try to reduce as we're working through the sizing tool application. And we're going to talk more about these values as we get into the presentation and how you work with them, because that's really what this presentation today is all about. Understanding these sizing parameters, how the loads affect those, and how you can reduce those. What are the different things in SpecSizer that you can do to size a smaller genset? So another question, I mentioned to you that I worked thousands of inquiries over the last decade, And a frequent question I would get, and I just want to make sure that I cover this, is, will SpecSizer derate my genset? And the answer is absolutely yes, it will. You've got a site application. It could be high altitude. It could be high ambient. There is an input on your on your site conditions page where you input your site conditions for altitude and ambient. We allow up to 3,200 meter on altitude, 10,000 feet, and up to 50 degrees C, 122 degrees F on ambient. So how would you tell if you had high altitude and you had high ambient? How would you tell then if SpecSizer actually derated your genset? Well, you would go to your Select Genset page, which we're showing you a clip of that here. There are two columns. There's a factory genset, EKW, KVA, and then there's a site genset, EKW, KVA. These are your ratings. The factory is your nameplate rating. That's what you would see, or our dealers would see in the price list, okay? And then the site rating is the D rate. That's really how much output power you have available. So you can always go to your site output and see how much your genset is derated based upon your altitude and your ambient. Good thing to know. So, in 101 we talked about the optimizer, talking about ways, things in SpecSizer, things that you can do to reduce the size of your genset. This is a really, really important feature of SpecSizer. Back in the old days of SpecSizer, it used to be called the Wizard. And there were so many times and working many, many inquiries over the years that I would see if the user of the tool would have just run the Wizard, they could have seen that they could have downsized their genset, the KW or the KVA, or the rating. And so what we did for the web tool, for SpecSizer Web, is we automated the Wizard, and we call it the optimizer. And so we run the optimizer in the background all the time. You as the user will input your site conditions on the Define Site Conditions page. You'll then add and sequence all your loads on the Add Loads page, and then you move on to the Select Genset page, third step of the sizing process. Just simply by clicking the Select Genset page, you size your genset, but the optimizer has run in the background automatically while you're doing this. There's a prompt there that you'll see. It's called Go to Optimize Scenario. If an optimized genset sizing is available, you'll see that note, and then you can check that out. You see here in this case, this again was an actual customer sizing file that I was working, trying to help the customer downsize their genset. You can see in this case, customer had sized a 920 kW, 1150 kVA genset. It was a 3512 cat genset. Now, simply by running the optimizer, which takes you back to the Add Loads page and resequences your load scenario, simply by running the optimizer, we were able to downsize the genset. So here then is just an image of what it looks like to go back to the Add Loads page. Originally, the load scenario for the sizing file was 4 load steps. The optimizer ran, resequenced the sizing file to 12 load steps. I think it might be noteworthy at this point to mention that if possible, you never want to size your genset with one load step because you'll oversize your genset almost always. So it's important then to multi-sequence your load steps. Sometimes the more load steps, the merrier. But that's really what the optimizer does. It gets away from that one load step. It'll actually find the optimal number of load steps if you select optimum step. We're going to talk more about that later. But here we're just showing the Add Loads page. Another thing that we want to talk about here while we're here is I call this another cardinal rule of sizing. The first one is that your size genset must at least meet or exceed you're running KW and you're running KVA. Well, this is another. And, it's an important rule. I provided training all over the world to really thousands of people. And I say, if you don't remember anything else that I tell you or talk to you about, remember this discussion about restrictor frequency dip and voltage dip. And what that is if you size or you sequence a load with a low, like 10% frequency dip or voltage dip, before, in your load scenario, before another load that has a more liberal or tolerant transient response, frequency dip or voltage dip, all subsequent loads will adopt that restrictive frequency dip or voltage dip of the earlier load. So does that make sense? So don't do it, because you don't want, for example, a load that could have been 30% frequency dip or voltage dip to become 10%, because you're going to oversize your genset. So again, I call this another cardinal rule of sizing. It doesn't matter whether you're using the Caterpillar tool SpecSizer or a competitive tool. It's just the way that sizing works. So again, remember it, don't do it. So let's go ahead and move on then. Remember we talked about how we ran the optimizer, a simple click of the button, and we sized a 1150, it was a 50 hertz project. We sized an 1150 kVA 3512 genset. Well, now we've been able to downsize the genset to a 500 kVA C15. So again, a substantial savings to users, to our customers. So let's go ahead and move on. We talked about the optimizer here. We talked about the auto automation of the optimizer. You can also manually run the optimizer. Back on the Add Loads page, there's a button that you see here. It's called Optimize My Loads. You can always check it out, see if the optimizer will size a smaller genset. So we're just showing that here, and we're showing the load scenario, the load profile. Let me just talk about for a minute what the optimizer actually does, what it will do, what the logic is. It'll group your loads into groups of largest to smallest voltage dip, and then within those groups, it will sequence your loads largest to smallest SKVA. So there's some logic there. And really, when we talked about that restrictive frequency dip and voltage dip, it's what we're doing is we're mitigating the effect of that with the optimizer, okay? Now, once you run the optimizer, it's going to rename your file. And all it's going to do is append the word optimized onto your file name. And you can see that here on the next slide here. You can see where we added the name, the word optimized. Now, your original file is always going to be saved in your My SpecSizer folder, but now your optimized file will also be saved in your My SpecSizer folder. So you'll have your original file as well as your optimized file. Again, we're back still talking about the manual optimizer here. Back some years ago, in the very beginning days of SpecSizer with the Wizard, we only allowed 20 load steps with the Wizard, with the optimizer. SpecSizer itself is capable of 99 loads and 99 steps. Well, it became apparent to me that we could be, or our users could be missing some opportunities because they needed the optimizer to consider more load steps. So we redeveloped the optimizer to consider 40 load steps instead of 20. And in addition to that, I mentioned this earlier, how do you know what's the right number of load steps to size the smallest genset? We developed a step selection called Optimum. It's the default. And if you simply choose or click on Optimum, SpecSizer will find the least number of load steps that sizes the smallest genset. So it's all done for you. All the work is done for you. However, you can, from 2 steps up to 40, you can force the step selection. Now, the last thing I want to say about this is that if you have a spec that you need to follow, say you have a load that has to be sequenced as a certain load step, you can always run the optimizer, and then on the Add Loads page, you can move that load to whatever step it needs to be, and then just simply by clicking Select Genset Page again, you resize your genset. And it will be a combination of the optimized sizing and wherever you've moved your loads to.
Well, Steve, you said it was the last thing you wanted to say about it, but we have a question for you. Is there a maximum number of steps?
Yeah, there is 99 loads and 99 steps. And Mary, again, over the years, I've looked at thousands of inquiries, and the typical sizing file I would say is somewhere between 1 to 40 load steps. I've really not ever seen any sizing files. It's been just maybe 1 or 2 that exceeded 40 load steps. So 99 loads and 99 steps fits for just about everything.
And how do we determine the appropriate number of steps? Do you have a guideline for us?
You know, I had mentioned that you never want to size your genset as just one load step, because you typically probably always will oversize your generator set. But I would say the thing to do, I don't know of any other competitive sizing tool that has an optimizer except for SpecSizer. I would say if you don't have to adhere to a specification and it doesn't require X number of steps and such sequence, I would say run the optimizer, run it as optimum step selection, and see what is the smallest genset KW KVA rating, and I would say that's the way to determine what's the optimal number of steps. Again, I think that optimizer is just a fantastic opportunity for anybody that has to do a genset sizing. Okay, let's go ahead and move on here. We're going to talk about some more tools. Now, what we're showing you here then is SpecSizer currently has 19 different load types. We're going to be adding more in the near future. But if you would look, you know, when you create a load, there's a load dialog that comes up where you input a lot of different values. You know, you've got a lot of different selections you could do on a pull down, but if you wanted to understand all the different inputs for all of the different loads in SpecSizer, what we've got here is a help document called Load Dialogs. It talks about all those different inputs and their effect on sizing. So, you know, when we talk about tools that we have, I just want to mention at this point that we have a lot of help files that we've created to support you with genset sizing, and you can contact your dealer or you can contact us, and we'd be happy to share those files with you as tools to help you with your genset sizing. So, talking about loads, another tool that we developed for the web tool, SpecSizer Web, that we didn't have with the old copy, the old version of SpecSizer, the PC-based version. We thought that it would be beneficial for the user to be able to create what I like to call a library load, and the tool is called a template load. So you can see here on this load dialog for a lighting load, it happens to be a fluorescent lighting load. You can see a checkbox for save as template. And if you would just simply create your load, whatever you want it to be, in this case it's a fluorescent, but whatever rating, whatever quantity, whatever transient response, that's the frequency dip and voltage dip, you can save it as a template load, and then you can have a library of loads that you use most often, and then you would go to the Add Loads page and you see that Add New Load button. You know, there are different ways that you can create loads in SpecSizer. You can use the load icons. I like to use those most of the time. Or you can use this Add New Load button. Once you hover over the Add New Load button, you'll see all the different loads that are in SpecSizer, but you also see, for some loads that can create template loads, you'll see a right arrow, an arrow on the right side of the box, and you'll see all the loads that you have created as template loads. So that's an easy access then to get to your library or your template loads. You can see that all there. Okay, another tool that we have developed for SpecSizer Web is, call it Compare Selected. You know, a lot of internet tools, applications, you can do a comparison of certain features, options, whatever, and that's just exactly what we've done here. If you click on the Compare Selected button, you're going to be able to compare the genset that SpecSizer has selected as the recommended genset for your input site conditions and your load scenario. They're going to compare that genset and up to 3 other gen sets that you choose. Okay, you would manually check up to 3 gen sets, click the Compare Select button, and you'll see these columns to compare all these different features and options. So here I'm just showing you some of the things that you can compare, and then we've also got a button. You can hide rows if the different rows, if all the information of all the data is the same, you can hide those rows. And then if you want to get back to your Select Genset page, all you have to do is click that Go Back to Generator Selection button. Pretty easy, simple to use. Now, again, here's some more information on Compare Selected. You can compare up to 41 different types of data. It's technical information about our genset, alternators, engines. So and I guess what I'll say here is that, I always appreciate the opportunity to go out and do training on SpecSizer, because it's a two-way thing here. I like to hear from our customers, from users. You tell me what's value added to you. So what we've tried to do here is provide technical data information that's useful to you as you use SpecSizer. But if you ever see something that you would like to be on here, then later in the presentation I'm going to provide an email address for you to contact me. Just send me an email and tell me something that you might not see here that you think might be value added for you. All right, so here we're talking a little bit more about, in addition to the Compare Selected button, you also have accessible from your Select Genset page a button called Compare Optional versus Standard. And really what this is about is SpecSizer is a full transient response tool. I get actual factory genset transient response data, and I get it at not only what we call a standard voltage regulator slope, but I get it at an optional voltage regulator slope. And what we do is load both sets of data into SpecSizer transient response data, and the tool automatically compares both sets of transient response data, and it will find the smallest genset based upon that comparison. So really that's what that button is doing here. It's showing you that comparison for a size genset for the two different types of transient response data, okay? Now, you can manage that back on the Define Site Conditions page. There's an option called Voltage Regulator Slope. The default is Best Fit. That automatically does the comparison for you, but you can also force the sizing to the standard voltage regulator slope, or you can force the sizing to the optional 3-to-1 voltage regulator slope. And why this might be important is, say if you already have a genset in inventory, or you've already purchased a genset, and maybe you're going to add loads to your genset, and you want to check the fit of adding those loads to your genset, then you would want to use the voltage regulator response that you have with your generator set. That can always be changed. The CDVR, or the adjustable voltage regulator, that does the 3-to-1. If you have that, you can always adjust your slope. But I'm just telling you here how you would manage that transient response for optional versus standard. Go back to your Define Site Conditions page and use voltage regulator slope.
And we have another question for you. Can we change the VDIP and FDIP permitted across the board for all loads after load add steps are configured?
That's a good question, Mary. I covered that somewhat in 101. Let me just take a step back here and say that on every load dialog, you have the capability as the user to determine what the frequency dip and the voltage dip of the load will be, anywhere between 3 and 35%. But this is a good question, because we've got an upcoming release for SpecSizer in December, and one of the new development features, options with the December release, will be a feature where you can change the voltage dip and the frequency dip across the board. You won't have to go back to the individual load dialogues and manage the FDIP, VDIP percent changes. So yeah, that's coming, and it's going to be here in about another 6 or 7 weeks. Good question, Mary. Yeah, we're still talking about compare optional versus standard here. Again, I've worked a lot of sizing inquiries over the years. This just happened to be an actual sizing file where, because we have that transient response strategy in SpecSizer, I like to call it volts per hertz optimization, where we compare a standard 2-to-1 or 1-to-1 voltage regulator slope with an optional 3-to-1 voltage regulator slope. Because we have that in SpecSizer, here's a case where we were able to offer not a 550 kW 60 hertz C18, but a 450 kW C15, a C18 versus C15. We were able to get a 100 kW reduction on that size genset. Okay, so another thing here that we're looking at is, you can remember I talked about you can show all rows, you can hide matching rows, but again, there's the go back to your select genset page. You need to click that button to go back. Okay, now, what we were looking at there is the gensets, the comparison on the compare optional versus standard button. But you can also see that comparison on the generator set details. When you are on the select genset page, every genset in the list has a view command. Every row, every offered genset, there's a view command at the end of the row. And if you select the row and select the view command, you then move on to generator set details. You can see here one of the pages with generator set details, the starting and selection analysis. And you can see here a block where the gensets are compared. And here again is another view where you would see on that particular sizing file the 550 versus the 450 kW genset. But here you also see your load's transient response. You see a graph for your load's transient response. And you also see, important to remember this and know, you also see a note called selection criteria that tells you what sized your genset, why it was sized, and what load step sized your genset. So if you're looking to downsize your genset, that selection criteria note is very important. So more about compare optional versus standard, because in my opinion it's a big deal to try to help you size the smallest genset possible. I mentioned that I worked all the transient response data for SpecSizer. If I look at our product across the board, we've been able to improve the frequency dip of our product by 6.6% across the board by providing the strategy for you. With the CDVR, the AVR 3-to-1 slope, better frequency dip, okay, and better recovery time, better genset transient performance. So primarily what you need, though, that helps you out here is if you have loads that have a low frequency dip but a tolerant voltage dip. Now, if we want to talk about the benefits of this strategy, again, SpecSizer is a full transient response tool. I mentioned that we get actual factory genset transient response data. It's not made up data. It's not equations on transient response. It's real data. Well, what we're able to do by providing that transient response, and by the way, a lot of small genset packagers do not provide transient response that way. They don't actually test their gensets for transient response. They use equations and numbers like that, and that doesn't get you even close sometimes. But what we're able to do here is some of the benefits of accurate transient response is, let's look at it here, better fuel consumption if you can size a smaller generator set, a smaller genset, less shipping weight, less transportation shipping weight, and also a reduced floor space. So, what we might be looking at here is we had a reduction from a C27 to a C18 or a 750 kW versus a 600 kW. So I went ahead and moved on here. What we're talking about here is tools and tips that you can use in SpecSizer to help you reduce your size genset. Remember, we started talking about running kW and kVA and duty point percent, and that's the only thing that you can do to reduce your running. And we also talked about inrush. What are the things that you can do to reduce your inrush or your starting kW and your starting kVA? There's something called reduced voltage starters. You find this on your 3-phase motor dialog. And so here we see I have provided you a table that you can reference later on here you can see in this table, one of the things that sizes a three-phase motor is DOL SKVA, direct on line or across the line SKVA. That's one of the things that is used to size your motor, to size your genset. And up there at the top, I show you the equation to calculate your ATL SKVA. Now, if you are able to utilize a reduced voltage starter, you can reduce your size genset sometimes significantly. Just as an example here are the different types of reduced voltage starters. A couple of them are current limited, like the soft starter, solid state, and the VFD, VSD. But I've circled here the percent reduced to for a reduced voltage starter. And so let's just look at this Y delta, the star delta. If you were not to use direct online starting, which is the most severe type of motor starting, and you were able to use a reduced voltage starter, say this Y delta, you could reduce the inrush of that motor by 67%, down to 33. 100 minus 67, 33%. So your inrush, your SKVA and your SKW is only going to be 33% instead of 100%. And again, this can provide you some significant savings, some significant reduction in inrush. Okay, this actually was a mock sizing that I created where I just show you a couple motors here and resistive load, and I walk through the different types of reduced voltage starter. Here, if you used, for this load scenario, a couple motors and a load, resistive load, if you size it as the direct on line or across the line, you size a 3,000, this is a 50 hertz, you size a 3,000 kVA C175, Cat C175, but if you use a soft starter, you're able to size just what? An 1,100 kVA genset. So, just for a couple motors and one load, you're able to significantly reduce your size genset. So I say, it's always worked in that cost versus benefit analysis decision. Would you rather purchase a reduced voltage starter, or would you rather purchase a larger generator set? Okay? So, you need to look at your application in part to make that decision, as well as the cost of the reduced voltage starter. Okay, here's a screenshot that I provided here where, before we were looking at how much the genset rating was reduced for the different types of reduced voltage starters. Well, always in the background behind the scenes, you're working with these sizing parameters, right? So I'm just showing you here, I talked about the Y delta, the soft starter, the direct online, the most severe type of starting. I'm just showing you here what happens then with the sizing parameters, how much they're reduced. So what you see here, what's important to remember is that the running demand is never reduced with reduced voltage starters on three-phase motors, but the inrush demand is reduced. And again, inrush is what? SKVA, SKW. And then KW is associated with the engine, right? And KVA is associated with the alternator. So you can significantly reduce the size of engine and alternator that's required. Now, another tip, important thing to remember, is you can get a lot of benefit here with the soft starter and the VFD, VSD. But what you need to be aware of, usually it's not a big deal, but just be aware that the soft starter and the VFD, VSD, they create some additional harmonics and distortion. So, just be aware of that, you got a load there that's no longer linear, it becomes nonlinear. Okay, so your genset sizing will account for that.
Just a little bit more about reduced voltage starters. What type do you see being used most often?
Another good question from the audience. Most of the sizing files that I've looked at over the years, I rarely ever have seen an auto transformer used, or resistance or reactance. That doesn't mean that they're not used, but again, I've looked at thousands of inquiries and tried to help downsize. Most of the time it's a soft starter or a VFD, VSD. They're the same thing. VFD is for 60 hertz world, VSD is for 50 hertz world. So mostly the VFD and the soft starter. And there again, it's a cost versus benefit. The VSD will typically reduce your inrush more than the soft starter, okay? And both of those will reduce your inrush more than the auto transformer and the resistance and the reactance. But a VSD will probably cost you more than a soft starter. So, just some analysis that you need to do. And again, we talked about the harmonics component. You're introducing some additional harmonics and distortion with the soft starter and the VSD. Now, while we're talking about motors, what application doesn't have motors as part of its load scenario? You've got motors, you've got non-motors, you've got linear loads, you've got non-linear loads. Well, a lot of your application is going to have motors. And so if we're looking for another way, another opportunity to reduce that inrush, remember with reduced voltage starters, we were able to reduce both the SKVA, the alternator, and the SKW, the starting KW, the engine. Well, here with low inertia motors, we're only able to reduce the SKW component of the inrush. And so here we're showing you the load dialog for a three-phase motor. Now this applies to only direct online motors. It wouldn't apply to reduced voltage starters. And so you've got an option called motor starting under load here. It's default checked on because what we always want to do is we want to make sure that you as the user of the tool that you never undersize the genset. So, more severe running here, actually starting in this case, would be with it checked on. Your motor actually starting loaded. But if you know that your motor is a low inertia motor, then you can uncheck that box and it would be a low inertia motor. Okay, I moved on here to the air conditioning load. Actually, I included this in my training kind of at a late date. I was just putting together a new training course for SpecSizer, and I was looking at the air conditioning load. Also mentioned that with the December release of SpecSizer, we're going to have a new chiller load that we're going to add in addition to the three-phase air conditioning load. But if you're working with the three-phase air conditioning load, there's something called EER, energy efficiency ratio, and it's significant what kind of impact the efficiency of that air conditioner has on your genset sizing. So what we're talking about here is that for EER, we provide you a range to set your EER at the default. We default it on at 11 EER. And so if you were just to do compare a sizing here, if you were just going to look at one 250-ton air conditioner load, and that's not unreasonable. A rental AC could be 80-ton. What you're looking at here, if you don't know, if you don't understand, if you don't check the spec on the efficiency of that air conditioner, you could be way off on your size genset. So, just looking at the comparison here, 6 EER, the bottom range, to 20 EER, it's a difference between sizing a 1250 kVA genset versus a 437 kVA genset. That is a significant difference in your size genset on just one load. And how many loads do you have for your application? You could have 40, 60 different loads. So it's just important to always understand your specification. A lot of this information you can get from the manufacturer, and just be aware of the efficiency, the EER component of an air conditioning load, and the impact it can have on your sizing.
A question came in while you were talking about low inertia motors. How do you tell if a motor is a low inertia motor?
Yeah, another good question from the audience, Mary. I would say, everybody understands inertia. It's how difficult is something to start and how difficult is it to stop. So, when you're talking about inertia, it really kind of has to do with mass. So say you had, a big fan, that's hard. It's hard to get going. It's hard to stop. That would not be a low inertia motor. If we're looking at something like a conveyor that doesn't have heavy parts, or a servo motor, or a light duty pump, that would be something like a low inertia motor. And there again, I think that's a really good question, because it's a good opportunity with low inertia motors to reduce your inrush for SKW by 15%, but you need to make sure that it's really a low inertia motor, otherwise you undersize your genset. But again, I think it's still fairly easy to see conveyor, light parts, light duty pump, servo motors, those type of things, low inertia motors. So, we already looked at generator set details on an earlier slide. We're just going to review that a little bit here, because it has to do with data, technical data, and when we're talking about tools that you can use to help you with your genset sizing, I think that's important. So here we're looking at, you're on your select genset page. You can view any genset that you want. You just simply click the view command at the end of the row. You can click any view command and see any genset. And so the first page that it brings you to, the default page, is the starting and selection analysis page, okay? So we talked about this, how you can see the transient response for the loads. You can see the selection criteria and know what size the genset and what load step size the genset. If you were trying to downsize the genset, what load step would you go to try to work with to downsize the genset? It's all right here. So we also we have some other pages that we can go to here. In addition to, before I move on here, I want to talk about voltage dip 1 and voltage dip 2. We talked about transient response, what it's made up of, frequency dip, voltage dip. Frequency dip is important, because if your frequency dip is too high, we talked about this in 101, you can stall your engine, you can stall your genset. So it's important not to undersize your frequency dip, okay? And it's important to understand your voltage dip, because voltage dip has to do with quality power. If you have excessive voltage dip, it's not like frequency dip where you stall your genset. Excessive voltage dip, quality power, your lights will dim, you'll trip circuit breakers. So, when you're thinking about voltage dip, then I talked about how SpecSizer is a full actual transient response tool. Well, if we didn't actually test our gensets in the factory, we wouldn't have that VDIP2 component. Okay, voltage dip 1 is the alternator only voltage dip. And a lot of sizing tools, especially if you're trying to size it by hand, you're only going to have that VDIP1 component from the alternator. You need to actually test your genset as a system and get the frequency-induced voltage dip. And so when I look at a sizing, I'll always come to the starting and selection analysis page, and I'll see which voltage dip size the genset, okay? And then I know if I'm trying to reduce the genset, what I'm working with, what I have to work with. So, but that's all they are. One has to do with alternator-only voltage dip. The other has to do with the engine plus the alternator voltage dip. So, we looked at the starting and selection analysis page. Another page, the second page, on generator set details. Remember, you got here by clicking the view command, is the alternator frame options. This actually came about a few years ago. I was down in Sao Paulo, Brazil, and I was doing some training for our dealer down there. And I had a dealer ask me, how can I understand other alternators besides the one that SpecSizer recommends with the size recommended genset? How can I understand what other alternators will work with that genset? Because they had product in the yard and inventory. And so I came back to Peoria and I concepted this alternator frame options table. And so what you can see here then is all the alternators and their RKVA value, all the alternators that will fit, that will work with your size genset. So It's a good opportunity if you need to upsize or oversize your KVA capability, your alternator. It's a way for you to see what will work. You can see the frame size. You can see whether the alternator is standard versus optional. A lot of good information about your alternator. Okay. Now, a third page that I designed and created for SpecSizer is something called Diagnostics, and it's probably more beneficial internally, but I would, over the years, I mentioned that I've worked thousands of inquiries, and, for me, just like you, time is important. I need to work an inquiry, whatever I'm working on, I need to work it as expeditiously as I can. So I was always looking for ways that I could pull in technical information about that sized recommended genset, get it all in one place, and if I was looking for a way to downsize the genset, or if I was just simply trying to figure out why the genset was sized the way that it was, what sized it. What I do here with Diagnostics is I pull in all the technical data for the genset, for the engine, for the alternator that's associated with the SpecSizer recommended genset, and then we've also got a block for project diagnostics to talk about, when was a project originally created, when was the last time it was revised. So a lot of, some additional technical information or data about the size genset. Okay, that's what you're seeing there, genset, alternator, engine, project diagnostics.
Here's another one. Are there other places that I can get and compare technical data in the SpecSizer tool?
Another good question, Mary, from the audience. Yeah, there is. I actually covered this in 101, but it's noteworthy to mention. We talked about when you're creating a genset sizing, you start out defining your site conditions on that page. You add and sequence your loads on the add loads page. You size your genset on the select genset page. You can also go to generator set details and see a lot of good technical information data. But then the fourth page would be your data and reports. And you can then move to data and reports, and you can create and print, create a file for your project sizing report, for your project load report, and for your transient performance report. And then back on the select genset page, noteworthy to mention is you can also create a guide spec. There's a button for guide spec back on the select genset page. So guide spec and your project sizing load report and your transient performance report. Your project sizing report, and it provides a lot of additional project, genset, engine, alternator, technical data and information. And it, as well as your transient performance report, will display, will tell you your recommended, your size genset's transient response at 25% load change increments up to full load. So a lot of good data there for you, the user, to get your hands on just with a few simple clicks of a button. We're going to talk about harmonics now. Why? Because we talked about running, and what you do to mitigate that. We talked about inrush, how you can work with that to reduce the size of your genset. And we also mentioned that, harmonics was an important part of this too. If you have nonlinear loads, they create harmonics and distortion. And so, in SpecSizer, some slides back, I showed you the add loads button with a list of different types of loads. Almost every one of those loads was a nonlinear load. The exceptions were resistive load, three-phase motor load, but some of the three-phase motor load starters are nonlinear. So almost everything of those 19 current loads in SpecSizer, almost every one is a nonlinear load. So, nonlinear loads create harmonics, they create distortion. That's a bad thing, okay? Especially if you have an application like a data center, it's a bad thing. So what you want then is you want your sizing tool to be able to mitigate the harmful effects of those nonlinear loads of the harmonics and distortion. So, SpecSizer is a global tool. It's available for 5 world regions. It's available at 60 hertz in North America and Canada, and 50 hertz pretty much for the rest of the world. Areas of South America and Saudi Arabia, 60 hertz as well. But you can choose up front SpecSizer whether you want to size a 60 hertz or 50 hertz project. But there are ways that the tool automatically mitigates the harmful effects of harmonics and distortion. And then I'm going to talk about here in a minute ways that you, the user, can mitigate the harmful effects of harmonics and distortion. So here we're just showing you what happens from a normal sine wave. When you get distortion, what happens? It's not a good thing for the reasons that I talked about. So let me just say here that, here's all the different load types. And again, most of these are nonlinear loads. So I don't think I have a slide on this, but just let me talk about it for a minute. That I think I covered it in 101. What SpecSizer will do automatically for you to handle harmonics distortion is upsize your alternator. Okay, SpecSizer will automatically increase your alternator's kVA if you've got over a certain percentage of harmonics and distortion. The other thing that SpecSizer will do automatically is change your genset's excitation from an SC self-excited to a PM permanent magnet or an AREP. So SpecSizer is doing some things for you automatically in the background to handle those harmonics and distortion. So here we're just looking at a couple different load types that are nonlinear loads, UPS, battery charger, and I'm just showing you here that you can make template loads. I guess the reason that I'm showing this here is I like to talk about the UPS load. Not only do we have a generic UPS load in SpecSizer today, but we've added the cat battery UPS and the cat flywheel UPS. So you can go out and you can create all kinds of template loads for the UPS and then warehouse them or store them here, and you can access them with your add new load space. So you can have all the different kinds of nonlinear UPS loads. So I'm going to go ahead and move on here. What I have here is an example of a nonlinear load, a UPS load, and I talked about the two things that SpecSizer does automatically, upsizing the kVA of the alternator, changing the excitation of the genset, but there's a couple things that you can do as a user to mitigate harmonics distortion. Those two things are you can add a filter. You can evaluate whether you can add a filter to a nonlinear load, and you can also increase, it's called pulse rectifier. We've got a range of pulse rectifier on most nonlinear loads from 6 to 24. With the UPS load, we've also got something called IGBT. But remember, the higher you get on your pulse rectifier, the closer you get to a linear load, the more you mitigate and reduce those harmful effects of harmonics and distortion. Okay, so here we've just got an example of a UPS load. I sized it originally as a 6 pulse with no filter. We sized the C27 750 kW, and then when we added a filter, we were able to reduce the rating from a 750 down to a 700 kW. But then what happens if we, just added a filter? What happens if we increase the pulse rectifier from 6 pulse, which is the default for these loads, to a 24 pulse? Remember I said the higher your pulse rectifier, the more linear you are, the less harmonics and distortion you have. Now we're able to reduce the size genset to a 550 kW C18. So we started with what? We started with a 750 kW C27. Now, this is just one UPS load. We're able to reduce the genset. It was a big UPS load, but we're able to reduce the genset, pretty significantly. Not just a rating, but a model. So let's go ahead and go on here. I just want to go ahead and reiterate that with the sizing tool, the wonder of it is you input all of your loads and your site conditions, and sizing parameters are calculated for you based upon those loads. And then it's really incumbent upon you I think, to understand what you can work with to reduce your genset sizing. Can you work with do you have a lot of inrush? You know, if your inrush is high compared to your running, then you have a lot of motors. And if your inrush is really high compared to your running demand, you know, you need to look for a way to reduce the inrush. And so how would you do that? You'd work with reduced voltage starters, you'd work with low inertia motors. Well, if you're running, you know, if you understand your application, and, you know, we talked about duty point percent, you know, you need to understand duty point percent. You know, if you've got a motor and a load factor, you only need, you know, say if you have a 10 horsepower motor and you only need it to be 10 horsepower when it starts, but you only need it to be at 60%, you only need it to be 6 horsepower when it runs, you know, that's your load factor. Well, you can reduce your load factor or your duty point percent. And so there are things that you can do to reduce your inrush, to reduce your running, to reduce your harmonics, and we talked about all those. So just kind of wrapping up here, we have a help link support inbox out there. It's called SpecSizer, support@cat.com. We've got a couple people manning that help box, and so if you need any kind of assistance on SpecSizer or genset sizing, as a customer or potential customer, as a user of SpecSizer, feel free then to email us at SpecSizerSupport@cat.com.
Steve, that's a lot of great information. But as we end our session today, what are the most important points to take away?
Yeah, you know, Mary, that's a really good question. There are a few things that I'd just like to briefly cover again before we end here. Number one, always check the optimizer. 30 to 35%. I mean, I've worked thousands of inquiries over 10 years. 30 to 35% of the time, the size genset could be reduced just by running the optimizer. If it moves a load in a step that you don't want it to be in, you can always manually move that load to another step, then resize your genset. And I think another thing, secondly, is look at your selection criteria note, okay? That'll tell you why your genset, and what size your genset. Was it voltage dip restriction? Was it running kW? It tells you what you need to work with, and it tells you the load step that you need to work with if you're trying to downsize your genset even further. Another thing is I talked about never, if you can help it, pack all your loads into one load step. You know, you will oversize your genset almost always. So multi-sequence your loads into multiple steps. And then, you know, we talked about that restrictive frequency dip and voltage dip rule, and, you know, and how really the optimizer helps, you know, offset, you know, restrictive loads being sequenced early in the load scenario. It puts them later, so loads that could be 30% frequency dip or voltage dip don't end up being 10%. And, you know, I said in one-on-one, and I'd like to say it again, that, you know, for us here at Caterpillar, primarily we're mostly interested in accurate sizing. I think that we've done everything that we can with the SpecSizer software to ensure that you, our user, hopefully our customer, accurately size your genset. But then what's also important is competitively sizing your genset, knowing how to work with it and size the best fit genset possible. So anyway, I just want to thank you for the opportunity to talk to you about these tools and tips that you can use to optimize your genset selection.
Thank you, Steve, very much. And now we have reached the end of our presentation, and if we didn't get to your question, we will follow up with you later via email. Thank you for attending today's webcast brought to you by Caterpillar. Please take a moment to complete the survey that has opened on your computer. To complete the form, please press the Submit Answer button at the bottom of the page. Thank you for your time. Your feedback is important to us. You can view and listen to this presentation on demand using the same link that you used to attend today. You'll receive an email as soon as the archive is ready. On behalf of Stephen Baker and Caterpillar, thank you for your time and have a great day. I'm Mary Windishar.